Hapo Burundi endelea tu hivyo.
Nani? Nyama tuso. Ahí para el camale.
Students, good morning. Can you hear me?
Morning.
Morning.
Good morning.
Oh, you can hear me.
Yes.
Yes.
Okay. I think then we can proceed. Today we shall be discussing a topic that we've covered in class. I hope you can be able to see the topic for today. What is the topic?
Newton's law of
motion.
motion.
Yeah, Newton's laws of motion. That is the topic that I'd like us to cover. So just 1 minute. I'm organizing. So we are discussing about Newton's laws of motion. It is a new topic. I understand that some of the students, you have a challenge as you go through this topic. So it is good that we try to tackle those areas that you feel they have a challenge to you. So we shall start with the first question. State Newton's first law. Newton's first law of motion. Lewis Hassan, state it for us. Lewis. Lewis Hassan. Mohammed Farah, can you hear me? Mohammed Farah. Mohammed Farah, can you hear me?
Yes.
It states Newton's first law of motion. Mohammed? Newton's first law of motion.
Said that an object in a motion continues to be in straight motion unless acted by an external force.
That is it. It states that a body at rest or in motion remains in that state unless it is acted upon by an external force. We move to question number 2. Define the term inertia. Don Masibai, can you hear me?
Yes.
Don. Mark Indasi, can you hear me? Mark Indasi. Mark Indasi. Mark Indasi. Victor Mugendi, can you hear me?
Yes.
Define the term inertia for us.
This is the property of a body to resist change in phase.
That is it. It is the tendency of a body to resist its state of motion or at rest. It is the tendency of a body to resist the motion or rest. So that is what we define as inertia. Then we move on to the next question. A passenger experienced a sudden push when a driver applied the brakes. State the Newton's law of motion that explains this occurrence. First of all, which Newton's law of motion is this? That is what we need to ask ourselves. Which Newton's law of motion is this? Is it first, second, or third?
First.
It's the first. So, and because we've been told to state, already it had been stated in question 1, whereby we state that a body remains at rest of motion unless acted upon by an external force. We move to the next question. The figure below shows a smooth card placed on the open end of a car. It should be can, not car. So a coin is placed on the card. When the card is horizontally pulled away suddenly, the coin drops in the can. Explain this observation. Explain the observation. Why do you think that coin is going to drop in the can? Mark Kabai. Mark Kabai, can you hear me? Mark Kabai. Some students, it appears, they have a problem with the sound system. So, Mark Kabai, can you hear me? Brian Ingwe. Brian Ingwe. Benjamin Maina. Benjamin Maina, can you hear me? Benjamin Maina. Okay, Don Masibai.
Yes. This is because the coin tends to maintain its state of rest.
That is it. Because the coin maintains its state of rest, that is why it will just drop into the can. Then we move to question number 5. A tout placed a bag on a carrier of a matatu. State and explain what happens to the bag when the vehicle starts moving suddenly. Suddenly. Mark Indasi, what do you think is going to happen? Mark, unmute yourself. Mark, unmute yourself. Mark Indasi.
Yeah, the bag will fall down. This is due to it trying to resist change since it was in a state of rest. It tries to resist the motion, hence it will fall. It will fall when the vehicle moves suddenly.
That is the answer. So you find that the bag itself is going to fall because it is tending to resist the motion when the vehicle will start moving suddenly. Go to Newton's second law of motion. State Newton's second law of motion. Dan, can you hear it? Duncan Ireri, can you hear me? Duncan Ireri, unmute yourself. Duncan, unmute yourself. Duncan, unmute yourself. Can you hear me, Duncan Ireri?
Yes.
Okay.
How umemwaga maji kwa choo? Acha ujinga.
State Newton's second law of motion.
Niende niangalie. Mbona nisiende niangalie? Ende umwage.
Duncan Ireri, unmute yourself and then you state Newton's second law of motion.
The acceleration
proceed.
is direct proportional to the magnitude of the net force and inversely proportional to the mass of the body and takes place in the direction of force.
There are some words that you have mixed up. You have an idea, but there are some words that you have mixed up. So Victor Mugendi. Victor Mugendi, can you hear me? Victor Mugendi. Victor Mugendi. Austin, can you hear me?
Yes.
Austin?
Yes, I can hear you.
Okay. Try Newton's second law of motion.
It states that the rate of change of momentum of a body is directly proportional to the resultant external force producing the change and takes place in the direction of force.
That is it. The rate of change of momentum is directly proportional to the force applied and they act in the same direction. For example, if you are pushing a vehicle in one direction, the amount of force you are going to apply will be directly proportional to the momentum that that vehicle is going to gain or that body is going to gain. Okay, before I proceed, I want to state that if you find that I've removed you from the group is because you have not used all your names. So I may not ask you a question. For example, there is a student who is naming himself as Test. If you don't change that name, I'm going to remove you from the group so that I can be able to deal with the students that I can ask questions. Now we move to question number 2. A resultant force F acts on a body of mass M, causing an acceleration A1 on the body. When the same force acts on a body of mass 2m, it causes an acceleration A2. Express A2 in terms of A1. Express A2 in terms of A1. So work on it. Do the calculation. I'm waiting for you to do the calculations. You done? I'm waiting for you. Are you through?
Yes.
Are you through? I'm waiting for you.
Okay.
What answer are we getting?
A2 is equals to A1 over 2.
A2 is equals to
A1 over
A2 is
2.
equals to
A1
1 over
2.
A1 over 2. So just 1 minute. I'm trying to okay. So we know the formula F is equals to MA. If F is equals to MA, we can see that from the question, a resultant force F acts on a mass M causing an acceleration of A1 on the body. So it means that this force will be equal to M A1. Then the question goes ahead to tell us that when the same force acts on a body of mass 2m, it causes an acceleration A2. So the same force F is acting on a mass of 2m. So this mass now is 2m. So this is going to be 2m. It causes an acceleration of A2. Now we have been told to express A2 in terms of A1. Because it is the same force, we equate this one to this. Therefore, it means that we shall have 2m A2 is equals to this M A1. That is M
Mom.
1. This M will cancel. And therefore, you are left with this A2 A1 over 2, or a half of A1. So that is the answer that is supposed to be there. Still move on. The next question, just 1 minute.
I can't see anything on your screen.
Huh? What are you saying? Can you be able to see whatever I'm doing, by the way?
No.
No.
Yes.
All of you?
Right. No.
Yes.
Yes.
Let me check how I can deal with this challenge. Just give me 1 minute so that I want to set this one in a way that you cannot be able to see on the screen. Just 1 minute. Give me 1 minute. I want to set it in a way that you can be able to see it on the screen.
Screen share.
Now, can you be able to see?
No.
Okay. Just Albert Charo.
You can be able to see now.
Oh.
No.
No.
Can you be able to see the screen, the questions?
No.
How now? How now?
Let me see on stop.
Mission my stuff.
Hakuna kitu.
You be able to see now? You able to see the questions?
Yes.
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 No.
Yes.
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 Okay.
So
Yes.
repeat question 2.
I'm experiencing a challenge of sharing on the screen.
So hiyo swali ulikuwa unafanya ilikuwa question.
So just 1 minute.
Simrudi question 2 ban.
Hold on, just hold on.
Maswali mbili Iliasa.
Alafu
Just 1 minute. Okay. So far, can you be able to see the questions?
Yes.
Students, can you be able to see the questions?
Yes.
Yes.
yeah.
Okay.
Yes.
Yes, we
Let's go to
can.
question number 2. Okay, let me just
Repeat
work
question 1.
on the space that we have at that position. A resultant force acts on a body of mass m, causing an acceleration of a1. We know that F is equals to ma. So here we are told that it is causing an acceleration of a1. So here we're just going to write a1. And then we are told when the same force acts on a body of mass 2m, it causes an acceleration of a2. The same force F is going to act on mass 2m. So m is 2m now, meaning that the second mass is double the first mass. It is going to cause an acceleration of a2. So here we're just going to write a2. Express a2 in terms of a1. Now, because we can be able to see that this force is the same, F is equals to this F. It is as well as good if we're going to fit the M, A1 is equals to this 2M A2 is equals to 2M A2. And because now you can see that M is the same, M is going to cancel. Finally, we are left with A1 being equal to these 2A2, 2A2. So finally, because you have expressed A2 in terms of A1, that implies that A2 is equals to A1 over 2. So that will be our answer, or half A1. We can now move to the next question. A body of mass m is allowed to slide down an inclined plane. The two factors that
Hello?
final velocity at the bottom on the inclined plane of the plane. So let's have 2 volunteers Let's have two students. Alex Apollo. Alex Apollo, can you hear me? Alex Apollo. Alex Apollo. Alvin Wafula. Alvin Wafula, can you hear me? Alvin Wafula. Alvin. Andrew Musioki. Andrew Musioki, can you hear me?
Yes.
Andrew Musioki. Okay. Give me one of the factors that can affect velocity. We are in question number 3. Andrew. Austin Kemenjo, can you hear me? Austin Kemenjo. Austin.
Yes. I can hear you.
Give me one factor that's going to affect the final velocity. We are in question number 3. Kemenjo. Mark Davis Maraga, can you hear me? Mark Davis.
Yes.
Okay, go to the next question.
Mark Davis.
Yes.
Okay, now move. You've already answered that one. Eh?
Pardon?
Okay, I want you to move.
Mark Davis.
I can hear you.
The other part.
We had question number 3. A body of mass m is allowed to slide down and state two factors that affect its final velocity at the bottom of the inclined plane. So one of the factor, Mark Davis.
You can say inclination of the plane.
You have an idea? Yeah, the angle of inclination is one. Angle of inclination. For example, when you are going to make a surface to be too slopey, you find that the body is going to move at a higher velocity. The acceleration will be higher. But if the angle of inclination is just a small one, the final velocity will be lower because the acceleration is not going to be too high. A body of mass m initially at rest is acted on by a force F for a time t. As a result, its velocity changes to a final value v. Show that the gain of kinetic energy E is equal to a half mv squared. So work on the question. Work on the question. Show that the gain in kinetic energy is equal to a half mv squared.
What
Work
of
on the
friction?
question. Oh, sorry. Yeah, the frictional force is still question number 3. Frictional force between the surfaces is still going to be a factor in this one. Thank you for that correction. Okay, we can work on this question number 4. Question 4. So let's go through the question. The body initially it was at rest. It is acted upon by a force F for a time t. First of all, we know that v squared is equals to u squared plus 2as. 2as. But this vu is 0 because the body is at rest, meaning that our v squared is equals to 2as, because the body is starting from 0. Then the next thing that we know is that when the body will be pushed, there is work done to push it. This work done is the one that is converted to kinetic energy. So here we need to note that the work done is equals to kinetic energy. So if this work done is equals to kinetic energy, then we know that to get work done, which is equals to force times distance. Distance, remember, we use a small s. But in this case, if you look at the question here, we have v squared is equals to 2as. Make this s the subject. If I make s the subject, then my s becomes v squared over 2a. V squared over 2a. Then this work done, which is force times distance, and we have said that this is the one that will be equal to kinetic energy. Note this part here. Then it means that this kinetic energy, Ke, will be equal to this force. So it will be equal to force times S, but S we have V squared over 2A. So we multiply all this with V squared over 2A. But now, the force, we know it is mg. I mean, we know Newton's law of motion, F is equals to ma. If this is the case, then our kinetic energy becomes force, which is ma multiplied by v squared, note this v squared over 2a. It is good for you to note that this a and this one is going to cancel. So this kinetic energy Ke, finally, we are left with mv squared over 2, which is a half mv squared, and it is this one. So that is how we can be able to prove such kind of a question. Then you can move on to the next. So we now move to the next question.
Isiradi.
Just 1 minute. So we work on the next. The figure below shows a stone of weight W placed on an inclined plane. If the angle of inclination is theta, indicate with the arrow 2 other forces acting on the stone. So this is just a stone that is acting based on an inclined plane. So which are the forces that are acting on it? So we have to use an arrow. We have to use an arrow. Which are the forces that are acting? Sorry, there are some challenges I'm going through, but I'm working on them. The forces acting, one force, it is moving towards this direction, and it is going to be the reaction force. I may not be able to get it for now, but it is going to be a reaction force that is moving that direction. Then the other force, so this direction of 6, we have a force, and it is the one that I'm referring it as the reaction of force. So here we are going to have the reaction force. Then when you place an object on an inclined plane, you expect it to move towards this direction. But now there is a force that is going to oppose it, and this force will be acting in opposite direction. So this force that is acting in opposite direction, we refer it as the frictional force. So here we shall have the frictional force. So those are the two forces that were required. Then we can move to the next. Those students who are writing, please just avoid it because it is making our work untidy. Then indicate how each of the forces in A is affected when the angle theta is increased. So frictional force, if I increase this angle, this body is going to accelerate more. So the frictional force acting on it is going to lower. Again, this body is moving downwards, the reactional force, we are going to increase the angle, the reactional force will tend to move towards this direction. And that reactional force, again, it is going to reduce. Then we move to the next question. So we can move to the next. Just 1 minute. So we move to the next question. Number 6. Car of mass 1200 kg moving at 90 kilometers per hour is brought to rest over a distance of 20 meters. Calculate the braking force. Do the calculation before I assist you. Do the calculation. Are you through? What answer are you getting? Anyone who is through? Mohammed Farah, are you through?
No.
Mohammed?
No.
Mohammed, are you through? Now, there are some students who are identifying our page. I think the best thing is to remove them. Who is through? Gilbert Kamau, are you through?
No, not yet.
Not yet.
Yes.
Mohammed Farah, are you through?
No, not yet.
Okay. I think then let's go through it. First of all, here we are told 90 kilometers per hour. We work on it. Just 1 minute. So our 90 kilometers per hour, we have to convert it to meters per second. Therefore, in this case, we are working with the 90. 90 we are multiplying by. So our 90 we are supposed to multiply it by, to convert kilometers per hour into meters per second. We multiply by a value by what? 5 over?
5 over 18.
5 over 18. So what do you get?
25.
We get 25. So it means that the initial speed is 25 meters per second. So with that speed now, we can now be able to work it out on our question here. So because we want to get the braking force, just 1 minute. We know that force is equal to MA. If force, oh, mine is not writing. Okay. If force is equal to M, here we don't have add to add plus 2AS squared, 25 squared, 2 A we don't know, then times S. S we can see. Here we have 2 times 20A, this is 40A. Bring it to the other side, it becomes negative 40A. Therefore, minus 40A is equals to, this is 25 squared, which is the same as 625. So work out, what is the value of A? 625 divided by negative 40. What do you have? Work it out quickly. 625 divided by 40. You are getting negative 15 points.
Negative 15.625.
That is it, negative 15.625. So with this in mind, now can we work out this force? Because we want to get the braking force, and if at all force is equal to MA, the mass of the vehicle is 1200. Therefore, this will be equal to 1200 multiply by, don't ignore the negative, by negative 15.625. 0.625. So our force therefore becomes negative what? We are multiplying by 1200 and you get 18,750. The answer is negative 18,750. So that becomes our final answer. Units, you must remember it. In case you ignore the negative, you have to show that the force is acting in opposite direction. It is opposing the motion of the vehicle. Now we move to the next question. A car of mass 800 is initially moving at 25 meters per second. Calculate the force needed to bring the car to rest over a distance of 20 meters. Sorry, just ignore this question because it is almost
17.
similar to the one that you've done. So they have the same concepts. Let's go to the next question. A body of mass 5 kg is ejected vertically from the ground when a force of 600 newtons acts on it for 0.1 seconds. Calculate the velocity with which the body leaves the ground. So work on the question. Calculate the velocity with which the body leaves the ground. Work it out. Waiting for your answer. Eric Mwangi, are you through? Eric Mwangi? Eric Mwangi, are you through? Ryan Gidai? Ryan Gidai? Okay, let's go through the question. A body of mass 5 kg is ejected vertically from the ground when a force of 600 newtons acts on it for 0.1 seconds. We calculate the velocity with which the body is going to leave the ground. So let us use the concept of impulse. Impulse, to get the impulse, it is the same as Ft, which is the same as mv minus mu. So that is where we are starting. So F is 600. So we place our 600 here. Is equals to, oh sorry, 600 we are multiplying by the time t of 0.1. 0.1 is equals to m is 5, multiplied by v. V is final velocity. The body, once you throw it at the top maximum height, the final velocity will be 0, minus mu. The mass is 5. U in this case, we don't know it. Therefore, we have 6 and 1 and we get 60. So in this case, it will be 60 will be equal to negative 5u. Divide every side by 5 and we get our u becoming negative 12. So it will be negative 12 meters per second. Why is it having a negative? Because this body is moving upwards in a direction that is going to oppose the gravitational acceleration. So that's why it is having a negative velocity like that. Then we can move to the next question, number 9. A bullet traveling at 300 meters per second strikes a thick wall and escapes on the other side of the wall in 0.005 seconds at a velocity of 100 meters per second. If the mass of the bullet is 20 grams, determine the average retarding force of the bullet. So work on the question. we get the average retarding force. So work on the question. Who is through? Let us work on the question. We are going to work on the question. So the bullet is traveling at 300 meters per second. So, and as it is traveling, we can see that this bullet, the initial velocity is 300. U is 300. And we can see it is going to move to the other side at 0.05. So time is 0.05. 0.005, that is. And it's going to move at a final velocity of 100. V will be 100. So this is 100. We want to get the retarding force. We know force is equals to MA. So can we first of all get A? From this values, it is possible to get A. And our A becomes V minus U over T. So in this case, our A becomes 100 minus 300 over the time of 0.005. So work out on this acceleration. So here we have in negative 200. We are dividing by 0.05 and we get negative 40,000. This is negative 40,000. Then, because we want to get the force that is going to retarding force, F becomes M of the bullet. The mass of the bullet is 20 grams, which is the same as 0.02. You have to convert into kg. 0.02 multiplied by negative 40,000. So we multiply by negative 40,000. And the final answer, we are going to have what?
Negative 800.
Negative 800.
Yes.
So this is going to be negative 800 newtons. Again, do not ignore the negative. You would rather leave that negative instead of ignoring. Or you just write 800 and then you state that the force is opposing the motion. Let's go to question number 10. A bullet of 25 grams is fired horizontally into a quick trunk to 50 centimeters wide. If its initial speed is 300 meters per second and it experiences a resistance force of 400 newtons, determine the speed with which the bullet emerges from the other side of the trunk. So work on the question before I assist you. Work on it. How many? Anyone who has gotten it, you can raise your hand. You have the button of raising the hand. Just press it and I'll be able to see. Abed Charo, you are through? Abed? Okay. Let's go through the calculation. Abed, you are through?
No, almost a minute.
Okay, Collins, can you go? What are you getting? Collins, can you go? I can see you are raising your hand. What are you getting? Collins. Collins, can you go? Just fight your Isaka.
Not yet.
Mohammed Farah. Mohammed, can you hear me?
Not yet.
Yes, what are you getting? Rafael Musioka, I can see you are lifting your hand. What answer are you getting?
100.
100. Julius Mokio, are you still getting 100? Julius Mokio.
I have 298.66.
Okay, 298.68. Anthony Nambiro, what are you getting?
100.
Anthony Nambiro.
I'm getting 100. 100.
You're getting 100. Okay, let's work out to see between those two answers what we are going to have. So first of all, because you have the mass here and we have the force, then why don't you first of all apply the Newton's second law of motion, which we know that F is equals to ma, so that we are able to get the unknown. Force in this case is 400. So we have 400 is equals to the mass, 25 grams into kg is 0.025. So we are dividing this by 0.025 multiplied by A. So our A in this case becomes, so we are dividing 400 divided by 0.025 and we get 16,000. This is 16,000. There is something that we need to note. It is experiencing a resistance force. If it is experiencing a resistance force, the force is opposing the motion. Therefore, remember, force is a vector quantity. And as long as it is giving an opposition or resistance, then this force is a negative. Therefore, it means that the body will be forced to decelerate. Therefore, it is going to be a deceleration. So for that A, you put a negative. Now, we have been asked to determine the speed with which the bullet emerges from the other side of the tree trunk. Why don't you apply the formula? V squared equals to U squared plus 2AS. 2AS. V squared in this case, it is the final velocity. And we don't know it. So V squared is equals. Initial velocity is 300. Therefore, we have 300. 300 is equals, oh, sorry. We are adding 2 A is negative 16,000 multiplied by the distance is 50 centimeters, which is the same as 2.5. So we are multiplying this one by 2.5. 2.5. Therefore, our V squared comes, this, we now work out these values. 2 multiplied by 2.5 is 5. 5 multiplied by 16,000, that is 90,000. So 300, this 90,000 squared minus 90,000, which is going to be equal to 0. So it means that that body will stop motion. Therefore, V is going to be 0. So that is going to be our final answer. Do you have some students who had gotten 0? Do you have some students who had gotten 0?
Yes.
So
Yes.
that is what was expected in that. Now we move to the next question. A block of metal of mass 40 kg requires a resistance force of 100 newtons to drag it with a uniform velocity along horizontal surface between the surfaces. So we calculate the coefficient of friction between the surfaces, work it out. Again, question number 11. Question 11.
Excuse me, teacher. I have a question.
Yeah.
Number 10. There's a problem.
Ask your question.
Number 10.
Number 10.
Yes.
Number 10.
Yes.
Okay. Let me go through it again. No problem. Number 10. First of all, the force is equal to MA. And the force in this case is 400. 400 being equal to mass 0.025. What is going to be our A?
16,000.
Divided by 0.025?
Negative 16,000.
16,000.
So, okay. We know out from V squared is equals to U squared plus 2AS. 2AS. So we want to get this V squared. So U squared is 300 squared. 300 squared plus 2A is negative. Oh, I got the mistake. Multiply by the distance of 2.5. 2.5. So this is 300 squared, sorry. Therefore, 2 times 2.5, that is 5. 5 times 16,000 is 80,000, isn't it?
Yes.
Therefore, we have 300 squared, which is 90,000 minus 8, yes?
Minus
So we get
80,000.
10,000, Studio.
Yes.
So thank you for that correction. So this is giving us 10,000.
10,000. Yes.
So it means that our V finally is equals to 100. Thank you so much for that correction. The answer is 100 meters per second. That is going to be our answer. We can now work on question number 11. A block of metal of mass 40 kg requires a horizontal force of 100 newtons to drag it with a uniform velocity along a horizontal surface. Calculate the coefficient of friction between the surfaces.
I have a question.
Yes, you have a question? Ask. Ask your question. I can't hear him. Let us proceed then. Frictional force. This is frictional force is equals coefficient of friction multiplied by reactional force. And reactional force, remember, it is mass times acceleration. So this frictional force, because this block, it requires a force of 100 newtons to drag it with uniform velocity. Then it means that frictional force is equals to 100 newtons, because when a body is moving at 100 at a uniform velocity, the only force you're going to apply is to oppose the frictional force. So frictional force is 100. Therefore, this 100 is equals to the coefficient of friction that we need multiplied by the mass of 40 kg. So we are multiplying this by a mass of 40 kg multiplied by acceleration of 10. So this is going to be 100 over 400, which is going to give us the coefficient of friction as 0.425.
I have a question.
So that comes up. Yeah. Ask your question.
Where have you gotten 10?
Yes.
Acceleration due to gravity. This one you can write mg. Are we together now?
Yes. Yes.
Ma, it is mg.
Mg.
So the answer becomes 0.25. Let's go to question number 12. An apple of mass 100 grams falls at a distance of 2.5 meters to the ground from a branch of a tree. Calculate the speed at which it hits the ground and at the same time for it to fall. Ignore air resistance. Work it out, assist you.
Imeanguka na hapo chini.
So waiting for you. Okay, let's go through it.
You've muted yourself. What light?
Can you hear me now?
So we can't hear you.
Can you hear?
Can't hear you.
We can't hear you.
We can't hear you.
What now? What about now? Can you hear me?
Yes.
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 I calling skill Mrs. K.
Yes.
Then here we were saying that potential energy will be converted to kinetic energy. mgh is equal to half mv squared. This m will cancel with this m, and you're left with g, which is 10, h, which is 2.5, is equal to a half v squared. So 10 times 2.5 becomes 25. Bring this on to this side. So you have 25 times 2, we get 50. Therefore, our v squared is equals to 50. So we get v. Get the square root of 50. 7 point what? 7.071.
Yes.
Yes.
7.071 meters per second. So that is the final velocity with which it is going to strike the ground. Then the time taken for it to fall. We get the time. Because this body is falling, it is a free fall. Then S is equals to a half AT squared. A half AT squared. S, we can say it is 2.5 meters. That is the distance.
We unafanya
2.5.
homework kama kazi yako tu ni kuangalia ma recordings.
Oh. Just 1 minute. So this is going to be a half. A is 10. Then T squared. Therefore, by 2.1, by 2.5, by 5.1, by 5 0.5. So our T squared is equals to 0.5. Therefore, our T becomes the square root of 0.5, and the square root of 0.5, we get 0.7071. 0.707071 seconds. Then we are being asked, assuming that the airport takes 100 milliseconds to come to rest, that by the time it strikes the ground and coming to rest, calculate the average force experienced by the apple. So this final velocity of striking the ground, we got it here. It becomes the initial velocity, and the final velocity of coming to rest becomes v. Therefore, our u is 7.071. V is 0. And it takes a time of 100 milliseconds. Milli you divide by 1,000 and you get time as 0.1. Now, can you get the acceleration? Acceleration in this case becomes v minus u over t. V we can see is 0 minus u 7.071 divided by t that we have found as 0.1. So it means that our acceleration is negative 70.71. So we want to get the average force experienced. Force is equals to ma. Force is equals to ma. The mass of the apple is 100 grams, that is 0.1, multiplied by 70.01. 0.71, sorry. So just 1 minute. So we are multiplying this by 70.71, and it is negative. So we multiply by negative 70.71. Working on it, then we shall have negative 7.071 Newton. So
0.001.
That becomes our final answer. I want you to copy question number 13, work on it before we meet again next lesson. Thank you so much for listening. Have a nice time.
Same.
Thank you.
Thank you, sir.
Thank you.
Same.
Thank you.
Thank you.
Through with the question 13.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
You are through with copy?
Yes.
No, no.
Yes.
No. Ndege.
Question 13. Yes.
Endelea kuimba tu ndege hapo ya ile radi na kupiga.
I finished.